Introduction to Belmont Forum Research Goals and Methods, Part 3. This four-part slide set was compiled by Vivi Stavro of the International Science Council, Shigumbo of START International, Vicki Lucas and Rowena Davis of the Belmont Forum E-Infrastructures and Data Management Project, and Marcella O'Hara of the Inter-American Institute for Global Change Research. Introduction to Belmont Forum Research Goals and Methods, Part 3. This four-part slide set was compiled by Vivi Stavro of the International Science Council, Sheikh Embo at the START International, Vicki Lucas and Rowena Davis of the Belmont Forum E-Infrastructures and Data Management Project, and Marcella O'Hara at the Inter-American Institute for Global Change Research. Part 3. Information Management, presented by Rowena Davis, E-Infrastructures and Data Management Project. The E-Infrastructures and Data Management Project is a Belmont Forum project to facilitate data management and sharing practices across CRAs, agencies, and teams. This section is a continuation of an integrated series that will introduce special data management considerations of the transdisciplinary research described in Parts 1 and 2. Transdisciplinary research is co-designed, co-executed, and co-communicated by a variety of stakeholders from academic and non-academic environments. Part 3. Information Management. The E-Infrastructures and Data Management Project is a Belmont Forum project to facilitate data management and sharing practices across CRAs, agencies, and teams. This section is a continuation of an integrated series that will introduce special data management considerations of the transdisciplinary research described in Parts 1 and 2. Transdisciplinary research is co-designed, co-executed, and co-communicated by a variety of stakeholders from academic and non-academic environments. Credit and reuse. Good data management practices enable achievement of the inherent goals of transdisciplinary research. Adherence to the methods of transdisciplinary research, coupled with good data management practices, will ensure that research products and the data supporting them can be found, cited, translated, used, and reused by a wide audience to further the goals of global sustainability and meet the Belmont Challenge. Reuse is facilitated by ensuring the data and its availability is communicated on many different levels, from the organizational through research and communication. Guidelines for attribution and security considerations in the use and reuse of data can also ensure that credit is given to the appropriate sources and does no harm to any party. Development of clear metadata and management methods encourage reuse of data and other benefits. For one, reuse can help maximize and efficiently disseminate the findings of field research, and this is a crucial practice for projects without a large budget for field work. Researchers can also get credit for their data when it is used and cited by others, and data reuse can increase the impact and raise the profile of research and researchers, as well as foster that collaborative air of cooperation that is so important to transdisciplinary research. As we learned in Part 1, transdisciplinary research addresses complex global realities and recognizes the inseparability of environmental, social, political, and economic problems. Therefore, this type of research encourages non-traditional research outputs. Often, the products of this research are not necessarily scientific papers or articles, but can be practical or action-focused materials that may be designed for specific sectors of the local public. An example of this could be when a weather scientist works with a social scientist to produce a population resilience report. In addition, since transdisciplinary projects often include research from multiple disciplines, teams can produce multiple data sets with more than one type of domain-specific schema. It's important that the connections and interactions between these data sets be documented clearly to enable transparency and reproducibility, and of course, reuse by future scientists. Some examples of transdisciplinary outputs could be policy briefs, expert testimony, opinion pieces, blogs. There are also decision-making support tools. There can even be school programs or specialized training curricula, building or engineering plans. And One of the Belmont Forum research teams has produced an art portfolio as a project output. It's important to be aware of the potential for many types of outputs from transdisciplinary research, as each will present specific data planning, management, and communication challenges. The data considerations in this presentation are general and not geared toward a specific type of research team. Instead, we present principles that can be helpful to all types of researchers and suggest resources that can enable teams to develop data management approaches specific to their area of research and their expected outputs. In 2015, the Belmont Forum adopted its open data policy and principles to promote standardization, accessibility, and of course, reuse from data derived from Belmont Forum funded research project. These principles are aligned with global open science practices, and they also closely remember the FAIR data goals to make research findable, accessible, interoperable, and reusable. And that's an international effort to coordinate data approaches. These principles are being phased in as data reporting management requirements for funded projects, and we'll talk a bit more about those in subsequent slides. Some basic tenets of data stewardship and priorities for all Belmont Forum generated data include discoverability. Data should be discoverable through catalogs and search engines. It should be accessible as open data by default and made available with a minimum time delay. It's understandable in a way that allows researchers, including those outside the discipline of origin, to use them. And as you can imagine, that understandable principle is very important to transdisciplinary research, as it enables people from other domains and other areas of science and other professions to really understand the importance of the research that's been generated. And finally, the data set should be manageable, protected from loss for future use in sustainable, trustworthy repositories. Considering data management from the outset of the project through its finish, following a full path data management cycle, ensures both compliance and efficiency in data planning and stewardship. Data management should be basically incorporated into the whole project design from the beginning. It should be tailored to fit different roles within projects. It should be outcomes based and relevant to project tasks. It should be shared with data professionals and archivists within an institution, and that's just a great approach to take to understand the avenues of help in terms of data fields that have already been set up for research teams, and to be able to access that help and know when to access that help. And finally, it should be connected with external groups such as repository managers and data publishers. These groups can be great resources for helping a team manage and format data to make sharing it that much easier. A key achievement of the E-Infrastructures and Data Management Project is the Data and Digital Outputs Management Plan, known as the DDOMP. This document asks strategic questions to help researchers anticipate their data planning and management needs, and it's available on the EINDM website at bfe-inf.org. Basic information on the expected value of the data sets, roles and responsibilities for data management within a research team, and how data management costs will be determined are asked during the pre-proposal stage, and then these themes are expanded in full proposal and award stages into an entire data management plan during the award stage. Developing goals and processes for data management early in the research lifecycle can really help teams organize and share their research with a lot more ease at later stages of the project. But no one expects these skills and knowledge for data management to grow out of thin air. We recognize that capacity building is essential to any data-related goals, so several resources have been developed to help researchers achieve the ideas in the Data Policy and Principles, and the DDOMP. The EINDM team has been working on tools that will really help these teams develop a feasible, effective data management plan and be able to answer the data-related questions asked during the pre-proposal, full proposal, and award stages. And these include the Data Policy Comparison Tool, the Data Skills Curricula Framework, and the Data Management Toolkit. They're all found on the e-Infrastructures and Data Management website. The Data Policy Comparison Tool enables side-by-side comparison of up to 3 data management plans developed by participating Belmont Forum agencies and partners. Its purpose is to help international teams be sure their data management plan meets their funding agency's data management requirements. It offers easy comparison of up to 3 of those data policies simultaneously, and policies are broken down by topic. Examples of topics include how and when data are to be publicly shared, or metadata, data citation, and attribution requirements, among others. The Data Skills Curricula Framework is a comprehensive list of training topics suggested for Belmont Forum research teams to achieve proficient skills in data-enabled science. The framework was developed in collaboration with data training agencies and endorsed by the Belmont Forum in 2017. Topics for principal investigators include ideas such as data management roles and responsibilities within a team, and also an emphasis on data management planning. The Data Management Toolkit offers free training resources for data management. Many of the resources fit into one or more of the topics developed in the Data Skills Curricula Framework. However, the Toolkit is a standalone resource. The DDOMP Researcher Guide provides resources specifically curated to address the questions in the Data and Digital Outputs Management Plan, and also empower research teams to develop a sustainable data management plan that promotes reuse and ensures credit. Furthermore, the DDOMP guide is presented according to the same stages listed in the DDOMP itself, and that's the pre-proposal, proposal, and full award stages. For those who delve deeper, the toolkit offers data management training by resource type, by geographic region, and professional role. A best practices and standards option links to training resources by topic, region, and organization. And a lot of these resources come from Belmont Forum agencies themselves. They're just compiled and put together in one place. The resources also come from globally recognized leaders in capacity building for data skills and management. All of the resources discussed in this presentation, as well as a great deal of background information on the process, on the collaborators and contributors to the e-Infrastructures and Data Management Project, are available on the website at www.bfe-inf.org. And we also have an active Twitter feed at _BFE_INF. So you are invited to check those out at any time.